Graph polynomial functions. Okay, so let's pull all this together. We've done a number of videos on all the pieces of graphing polynomial functions. In this video, we're going to use the end behavior, the x-intercepts and multiplicity, the y-intercept, symmetry, and turning points to sketch the graph of a polynomial function. Now we know a lot, and I didn't list it all down here because it probably would have taken the entire page, but we'll go over it as we go through our example. To sketch the graph of a polynomial function, and again, the key word here is sketch. We just want to get a general idea of what it looks like. We want to first determine the end behavior using the leading terms, coefficient and degree. We want to second find the x-intercepts by setting f of x equal to 0. And we want to note each x-intercept's multiplicity. Third, we want to find the y-intercept by computing f of 0. Fourth, we want to use any possible symmetry to help us visualize what the graph is going to look like. And five, we're going to kind of check ourselves by using the fact that the maximum number of turning points is the polynomial's degree minus 1. Okay, so let's get started. Move myself up here. So use the let's try that again. Use the 5-step strategy above to sketch the graph of f of x equals x cubed minus 3x squared. Okay, our first thing was the end behavior. What does the graph look like as we approach positive infinity, or as x approaches positive infinity and as x approaches negative infinity? As you recall, we look at the leading term, which in this case is a positive 1x cubed. I'll make that a 1. So we know it's an odd polynomial. So the end behavior is opposite. And it's a positive 1, so it falls to the left and it rises to the right. So this tells us it falls to the left and it rises to the right. Okay, let's take a quick little sketch of this. And again, we're just trying to get an idea of what's going on here. It falls to the left and it rises to the right. And I have no idea where these take place. They could be all to the right of the y-axis. It could be all, well, it's got to cross the x-axis somewhere, but it could fall starting up here someplace. I don't really know. I've just started a brief sketch to see it. Okay, second step would be our x-intercepts. And this, of course, is when f of x is equal to 0. So let's take our function, x cubed minus 3x squared, and let's set it equal to 0. And let's do some factoring and some work to see if we can't come up with our zeros. So I see a greatest common factor of x squared times x minus 3. Okay, so it's factored. I have zeros at 0. And this 0 has a multiplicity of 2. And my second 0 is at positive 3. And this 0 has a multiplicity of 1, which I can write right there to make sure we see it. So we have zeros at x equals 0. And this has multiplicity of 2. That's an even multiplicity, which means it touches the x-axis at x equals 0 and it turns around. And I have a 0 at x equals 3, and this has multiplicity of 1. That's an odd multiplicity, which means it crosses the x-axis at x equals 3. So starting here, we'll draw another sketch. Okay, at 3, we're crossing. And at 0, we're touching and turning around. Well, if we're going to be going down here, my guess is, okay, we're probably going to do this. And then we're probably going to go like that. Okay, we've got to have ourselves going down somehow. And we know that we don't have any zeros over here, any more zeros. And we've got to go up from here. We got to cross this. We have no more zeros other than 3. And so it makes sense that it's going to touch at x equals 0 and turn around. And it's going to cross, increasing from left to right at x equals 3. Okay, let's take a look now at our y-intercept. That might make a change here, but I'm guessing it's the origin. We can check it here. This is, of course, when x is equal to 0. And so what is f of 0? Well, that's going to be 0 cubed minus 3 times 0 squared. Right here, 0 cubed minus 3 times 0 squared. And that is 0. So our y-intercept is 0, which tells me I feel pretty good about this. Okay, I still have the same. This is the x-intercept and the y-intercept is 0. This is still 3. So I feel pretty good about what is going on with my sketch here. Okay, it looks like it's making, let me give it a little bit more room so you can see it. Looks like what I have up here, there's no other place it crosses the y-axis because there's only one y-intercept in a function. And so that looks like what we've got going on here as a sketch. Okay, give me a moment here. Let's turn my paper over. And let's take a look at the last 2 steps of our little 5-step process. Okay, so step 4 is symmetry. Okay, we want to look at y-axis and origin symmetry. So let's first look at y-axis symmetry. And we talked about first replace the f of x with a y. Okay, so y equals negative x cubed minus 3x squared. And now to find y-axis symmetry, we replace the x with negative x and see if we get the same thing. Do a little math on it. Simplify it. Okay, so this is y equals, well, this is going to be negative x cubed minus 3x squared. And you can clearly see that those are not the same. The second term is the same, but the first term is the opposite. So as far as y-axis symmetry is concerned, nope, we don't have any. Okay, how about origin symmetry? Okay, so again, we're going to replace the f of x with a y and copy down the function. Now let's replace the y with a negative y and the x with a negative x. And then let's do some simplifying. Well, the left side is negative y. The right side is negative x cubed minus 3x squared. Multiply everything by negative 1 on both sides, and I get y equals positive x cubed plus 3x squared. And you can see with the original, well, the first term is identical. They're both positive x cubes, but the second term is the opposite. This is a negative 3x squared. This is a positive 3x squared. So yet again, nope. This graph will not have y-axis symmetry or x-axis symmetry. Well, if we go back to what we had, I'm not going to resketch it, but it's pretty clear looking at what we had here that we didn't have any symmetry going on. I don't see any y-axis symmetry, and I don't see any origin. I think I misspoke earlier. I don't see any origin symmetry spinning it around. I think I misspoke and said x-axis symmetry accidentally. I meant to say origin symmetry. Okay, and number 5, let's take a look at our max turning points. Maximum turning points. We're going to kind of check ourselves. Well, we know we have a 3rd degree polynomial. So we know that this means the max number of turning points is 1 less than the degree. So the maximum number of turning points is 2. Maximum number of turning points equals 2. And that's just checking to make sure that our graph makes sense. So let's take a look. I think we feel pretty secure with what we have. We know we have an x-intercept here as well as a y-intercept here. We know we have an x-intercept at 3. We know it's falling to the left. We know it's turning at x equals 0 and coming back around. And then it's crossing at 3 because it rises to the right. You'll note I have 2 turning points. It turns right here, and it turns somewhere in here between 0 and 3. I have no idea where, but that gives me a nice sketch using all the information. And yes, I have 2 turning points. I don't have 3 or more, so my max turning points quick check tells me that I think I'm pretty good. So there you have it, how to use a lot of the stuff we've learned to just kind of sketch the graph. Now let's do a quick look at this on the calculator. Y equals, looks like I was already putting it in here. Let me get my graph out. X cubed, yep, I put it in. So I have x cubed minus 3x squared. I left it in there. And when I press, there it is right there. Now you'll notice this one seems to fall and rise a little faster than what I have. That wasn't the goal. There's a turning point right there. That's a bounce off of 0, hit 0 and turn. And then there's a turning point here and a cross at x equals 3.